This is the 2.5 podcast on vectors, and the main point about this one is talking about parallelograms and finding the resultant from a parallelogram. And to find the resultant of two vectors, construct a parallelogram wherein the two vectors are adjacent sides. The diagonal of the parallelogram shows the result. And you've already done this when you did the opening part on vectors. You just didn't realize you made a parallelogram. You made two triangles, which essentially was a parallelogram. So, the sum of two vectors is called their or more vectors is called their resultant. When they are in parallel, meaning one next to another, like this, if they are in the same direction, then they add. But if they are in opposite directions, they subtract. Let's look at this one. There are two vectors. One is Nelly's weight right here. Let me put it in yellow, and then the tension on the wire. Put that in yellow right here. And so the tension in the rope. I'm sorry, gave away the ending. The tension in the rope is going to be 300 newtons because her weight is 300 newtons. Now let's have two ropes attached to the ring instead with two scales here, and you can see that each scale is going to have a reading of 150 newtons, and if you add those together, it's going to be equal to 300 newtons. So each of these 150 newtons is now half her weight, and once again she's in mechanical equilibrium because the sum of the forces is equal to 0. 300 newtons of weight down to 150 newton tensions upward. So here's a parallelogram rule. We have two vectors, and in this case they're at right angles to each other, and what we do is we draw a dotted line parallel to perpendicular to the two vectors, but parallel to the other vector. And what you end up with, where those two dotted lines meet, is the end of your resultant. And you just draw a line from here to here, and you've drawn your resultant. That diagonal is the resultant. Well, let's say we have two vectors that are now equal in magnitude. You still do the parallelogram, but in this case it's going to be a square, and in that case the resultant is going to be the square root of 2 times either one of the vectors. Remember, these two vectors here are equal, so it doesn't matter which one you multiply times square root of 2, it's going to be you're going to get the same result. In this case, if R is 100 newtons, for instance, then in this example we have 141.4 be the resultant. So here's a question: which of these two ropes is going to have the greater tension in it? Is it going to be less than one, or greater than the other, or what is it going to be? So we'll use the parallelogram to determine this. Let's look. The resultant R here has to be equal to her weight. So the first thing that you would do is draw the resultant R here, and if you draw your diagonals downward here, you end up with the two resultants there. So what we do is we find out what Nelly's weight is here. We draw a dotted line to represent our resultant here that is opposite of it. Then we draw diagonal lines down the side until we hit the ropes. Hit these two ropes right here. And at that point where the green dotted lines reach the rope, that's the tension. So here's the length of the two tensions right there. And adding these together, it makes this dotted line here, and it'll be equal and opposite the tension, her weight. Now, if you increase the angle of the ropes, see that this angle here is greater than this angle here on the previous slide, you can see that the tension in the ropes gets greater and greater. In class, I'll have you try to hold a book with a wire or a rope, and I'll have you move your arms apart, and you're going to see the tension is going to get greater and greater in your arms to the point where you can't hold the line can't hold the line straight and horizontal. So let's look at if she has two ropes here. You can see that we approach it the same way. We draw a dotted line that's equal and opposite our weight, and that's the resultant we need. Then we draw our two parallel lines, perpendicular lines. They're parallel to the rope, but they're perpendicular to the other rope, and that's where our the end of our two components will be. And you can see that as the rope gets at a wider angle, that tension in that rope is going to be smaller than the tension in the rope that is more in a up and down orientation. So that rope, this rope here, is going to bear more of the load. Now let's apply that. If we hang a let's say if you hang a clothesline vertically like this, like in a tire, there actually is less tension in that wire than if you hang it horizontally. And that may not make sense to you, but let's look at it again here. Once again, notice the angle. You have a very small angle here, you have a very big angle here, and the bigger the angle between the two sides of the rope, the more tension there's going to be. So you can see very easily how this will snap because there's going to be more tension in this rope, and this will be just fine because there's just going to be tension that's equal to that guy's weight. Now you should be able to answer this one easily. Which one of these two ropes is more likely to break? The one with that are going straight up and down to support the weight, or the ones that are on a wider angle? And the answer is, of course, that the ones that are in a wide angle, the angled ropes, are more likely to break than the vertical rope. So this one is going to be more likely to break than the other one. So, are you able, what this is asking you is, can you hold a horizontally stretched guitar string and suspend a weight on it? Can you hold it horizontal? Can it remain horizontal? And the answer is, without any sagging, the answer of course is no. Even it doesn't matter how much the weight is, there's no way it can hang horizontally, because the guitar string is going to have to sag a little bit to form a resultant parallelogram to have a vertical upward 10 Newton resultant. It's just like this situation. It's one more. It's going to have to sag at some point just a little bit. So how can you find the resultant of two vectors? The way you find the resultant of two vectors is construct a parallelogram, and the two vectors are going to have adjacent sides, and then the diagonal of that parallelogram is going to be the resultant. Now there's a little quiz at the end here, and we'll just go through the quiz very quickly. You can pause it and try to answer the questions on your own.